Good evening, everyone. I think this is going to be one of the last few sessions, so I won't bore you with too many technical details. I'll try to keep it with most of the interesting stuff and stories. I'll talk about three major things: why we are talking about healthcare and AI, second, how we are doing it, and what we are doing. So, what problems are we facing in healthcare? I'll talk majorly from the thought process of neurotech. What kind of problems are we facing? Number one, delayed diagnostic. Late diagnostic makes wrong diagnosis, wrong treatment, no improvement, adverse side effect, so on and so forth. Why is this happening? This is because of the lack of information. Does it mean that uh, doctors are doing something wrong? No, it means that they are not having enough information to take good decisions, to take accurate decisions on correct time points. The reason is the universe and how the brain is constructed is really complicated. You can see how difficult it is to analyze a universe. It is similarly very difficult to analyze a brain. What we are doing is we are constructing map of the brain, which means not just the structural definitions, but also where the activity of the brain lies. What part of the brain is actually helping when I'm talking? What part of the brain actually does vision analysis? What part of the brain actually helps in motor and sensory motor? These are very important because in such cases, the surgeries will be improved, the treatment will be improved, and possibly the rehabilitations will also be improved. Now, I'll talk about three major use cases on which we are working at the moment. Number one, what does the neurosurgeon wants? He wants to know if he's performing a surgery from where to enter the brain. Which part of the brain is very crucial and he should leave that region without disturbing. What part of the brain will provide vision area and he should not touch that part. So if you will see, here is kind of tracts which are roadmap of the brain. This comes from a modality of imaging called as diffusion tensor imaging or DMRI. Here we are giving around 8 to 9 major tracts in the brain, and together with the vision network, it looks something like what is displayed on the screen. So this is what becomes very important for neurosurgeons to look at before performing the surgery. Then what are neurologists looking for? How it is useful for neurologists? Neurologists can look at this and do cognitive mapping as well. So for example, if somebody is suffering from dementia disorder, who's having memory loss and who's having difficulty in conducting day-to-day life, then these kind of map will help them in locating which area of the brain they should be targeting to and therefore provide therapies on top of it. Third, we are working with psychiatrists to generate the reports for psychiatry as well, which means that if, again, there is some difficulty in a person's memory, retention, speech, it can be detected which area of the brain it is affecting, and that can be analyzed. Here, it is more therapeutic as compared to surgery-oriented. Now, from where is all these coming? This is coming from three major types of data. You must have seen in Google Map, you need to understand the destination, then you need to understand the road maps as well, and then the traffic maps. So three components are very essential. Similarly, here we have three types of data sets: structural MRI, DMRI, and functional MRI. This is based, the tracks are based on the water diffusion happening in the brain, and the last one, functional MRI, is based on the oxygen exchange happening in the brain. So it looks so beautiful. Does it come to us in the same way? The answer is no. What we get is a black and white old movie kinds of picture. Basically, here we are getting structural MRI, which is like snapshot of the brain, which provides us the structural detail of the brain. DMRI, these are very grayscale images because these are just gray intensities of oxygen changes, and this is 4D image, which means 3D for a time series. 7 minutes is what we capture the data for. And after processing also, it all looks black and white like Meena Kumari in old Hindi movies, right? And when we talk about DMRI, this is where we get the water diffusion images, and this is where the tracks are processed. After these three images, if I want to, excuse me, if I want to play this video. Yes, so if you see from those kind of images, if we have to take out the details, you see there are fibers which are visible in this one. These are the kind of details we would require to provide to doctors so that they can take decisions of what they are doing for the treatment. Now, in such cases, AI becomes a necessity and not just additional toolbox, because these are a very high multidimensional data set. When we are talking about functional MRI, it is really complex, like I mentioned, 4D data set, and it becomes, it is not humanly interpretable at all. Doctors are not having these informations at all at their fingertips. So, in such cases, we are doing processing, extracting, classification, and information engineering. What it means, the processing, when we are taking 4D images, then there are around 26 steps where we are doing processing. Some are very simple statistical methods, and some are like segmentation of the brain, extracting the skull, extracting the brain and removing the skull. Then if it is tumor case, then we are doing segmentation. So such processings are required, and all the three modalities are having their own steps, where not necessarily in each step we would require AI, but in many of the steps we would require AI. Extracting the relevant signal. Now, when we are talking about language region, when we are talking about vision, etc., so on and so forth, we need to understand that these signals are not coming to us at different time point, which means these are mixed with each other. We have to classify them. We have to understand which part of the brain corresponds to which particular signal. Then classification, inferencing, and information engineering. We have to give back the information to doctor in the form that they see. They don't want numbers. They want something which they can tangibly use in their neuronavigation system. Neuronavigation system is a device which sits in their surgery theater while they are performing the surgery, and these are the data set which goes to them, and they can see it before performing the surgery. So we are formulating systems. The kind of systems that we are formulating are systems to estimate the activity, connectivity in the brain, systems to map the eloquent cortex changes in the brain. Eloquent cortex are the major changes happening in the cortex, like cognitive changes, so on and so forth. Then system for 3D mapping and reconstruction of activity of the brain, and system structural mapping, classification, and tumor segmentation. So these are some of the systems. Now we work with the frequencies. That's why this is a very simplistic understanding of how it was devised. The frequencies which are coming, we are locating those frequencies, and then using the true sources, we are identifying and mapping it, the components on the brain space again. This seems very simplest, but there are a lot of processing happening at that part as well. Now we are already in around 30 hospitals. We are CDSU approved. That means we have license to be in these hospitals. We are now part of around 370 surgeries already in and outside Bangalore, and a lot of other treatments as well. So this is about a lot of validations are required in any system which is doing any such task, because it is ML in healthcare, and a lot of possibilities are there still, that we have a lot of experimentations to do, so many different things that we can actually do. One is generative AI connectomics model. Connectomics is basically the tracks as well as the traffic map of the brain together is called the connectomics. Now generating AI models on top of it, where we can use generative AI, has a huge scope. It opens up so many new use cases to understand, to do drug development, possibilities of new molecules coming out for treating such different various uh, deficiencies in activity, so on and so forth. So survival analysis, post-surgery, improvement and rehabilitation plans, this is where I believe that within 1 or 2 years there would be amazing treatments coming out, because Gen AI has a huge possibility in improvement and rehabilitation plans. Drug validation for the model for pharma companies, and epileptic network predictions. These are some of the things which we have already started looking into, and we believe that there would be soon new discoveries in these areas. One patient gives us really huge data set, around 20 to 50 GB. Once we process it, there is possibility of using that data set into various forms, and that is why it is possible to do so many models from a limited set of data. Now, there are other companies you would have known about in the neurotech space, and these are all the possible intelligent systems in healthcare which one can work at. Right now, healthcare is still to see the revolution that had happened before in finances. We have not seen that revolution in healthcare yet, and it can happen in the coming years, and we hope for the best. Some of the things where the healthcare startups or any other companies would require to run extra mile are on the validations, like proving the underlying sciences, science behind the product they are making. So understanding the science itself, like we are working with tumors, so understanding how the brain responds to the tumor, how the features should be changed, because the tumor has to be looked into under certain eyes. It has mass effect on the brain, right? Since behind the product and algorithm itself, there should be a lot of understanding. Processing of data is correct or not, matrix considered is correct or not. So a lot of validations is required in healthcare, which is more than any other non-healthcare company does. This is our very interesting team. We have 2 members of the team joining in this auditorium as well. And thank you so much. If you have any questions, I'll be happy to answer.